Assalamualaikum and very good days. So for the class today, we will continue for the new chapter, chapter 4, vector calculus. This is the last chapter. So I hope all of you can be the end of the class. We all know how to use the vector calculus. Okay, this is the subtopic that we will be learn in this chapter 4. Okay, so first of all, I will introduce you what is the scalar field and vector field. Okay, for the scalar field, if the every point x, y, z have the associate with the scalar quantity, the function, function in the term of the scalar quantity in the term of the function, the scalar field is said to exist in the region R. Okay, so contoh scalar quantity. Okay, let's say we have the function of the phi equal x, y, z plus 1, let's say okay, t equal exponent negative 3x kuasa 2y ke over z ke. So this one we call it as the scalar field. Okay, scalar field. Okay, meanwhile for the vector field, okay, this topic will be focused in the hours chapter 4. Okay, in this hour chapter 4, if the every point they have point in the axis x, y, z associate with the vector quantity. Okay, vector quantity f x, y, z. So how we can to derive for the vector quantity? Vector field is the set to exist in the region R. So the vector different between the scalar and vector. Kalau scalar field in this term, okay, kalau vector field in the this term. So vector field usually in the form of the HK. Okay, so for the in this others words, so vector field is the system. Vector field is the system vector either in 2D or 3D. 2D or 3D. Okay, kalau this one surface in term of the surface. Kalau 2D, it is in the plane, in term of the plane. Okay, so we have the direction okay. So dalam bentuk 3D yang diberi, so given by vector function. Tadi saya dah explain vector function. So vector function dia dalam bentuk f x, y, z. Vector, maksud kalau scalar function tadi untuk f f x, y, z. So different this one untuk scalar function. Okay, here for the vector field. So in 2D, so example in 2D, they have the f x, y, so equal, okay, pi plus qi, okay, qj. In this one 2D, kalau 3D, if the 3D for the vector system, so the pi plus qj plus okay. So the base they have the difference between the scalar field and vector field. If the scalar field they don't have the I, j, k. For the vector field they have the direction I, j, j, k. So p, q, r, okay, p, q, r ni. So for the p, q and r, okay, so here p, q and r here, okay, q, p here is the whatever, okay, whatever define function on the plane. So p, q, r so maybe can jadi x, y ke, okay, z kuasa 2y ke, okay, anything that related to the function x square ke and so on okay. So this is the definition of the vector field. So how we can sketch the vector field? Okay, so let's say they given the vector field. Okay, they given the vector field. fxy equal to 2i. Let's say this one for this plane 2D. So how we can sketch the vector field? We just plug it in the any value. Plug it in any value. Okay, any value. That means any value of the x, y. Any value of the x, y. Okay. So how you can sketch the vector field? So this one xy. So in the term of the xy lah. xy. Okay, in the plane xy. So how we can? We plug it in any value. So if you plug it in 0, 0. So what will happen here? Remain still remain. You put 0, 0, it still remain. So 0, 0 here to 2i, moving to the I, moving to the x lah. Dia moving 1, 2. So dia moving kepada 2. So ni point 0, 0. Let's say you put the point 2, 2. Okay, point 2, 2 here. Contoh So 2, 2 here. So the 2, 2 equal, letak f 2, 2 still equal to I. Letak f 0, 0, the answer still same to I. So all the point is to I. Sebab kat sini in this component they don't have the any function, okay, any variable. So at the point 2, 2 dia still lagi 2 to I. Kat point contoh 1, 1, negative 1, negative 1, so you still 2 point. So bila you gabungkan semua akan jadi any point lah. Bila you masukkan plug in for the any point, so you dapat here. So the whole the figure here, so this one represent for the vector field. This one we call as the vector field, the system. Okay, the system. Okay, the bunch of the vector field atau whole bunch of vector function for 0, 0 here, for 2, 2 here, for 1, 3 here. So all the point have the vector function. So the bunch, so sekumpulan lah, sekumpulan we call as the vector field. Okay, let's say we do for the other example. Okay, so the given the f xy equal negative xi minus yg. Okay, let's say the given in. So you need to sketch the vector field. So let's say you substitute for 0, 0, so equal to 0. So let's say you plug it in for the 1, 0, so negative I 0. So let's say 2, 1, so equal negative 2 I negative j. Okay, let's say f negative 1, so they equal I plus j. Okay, let's see macam tu lah. So you plug it in for the any value and then you plot this one xy. So xy the plane in the term of the xy. So at the point 0, 0, 0. At the point 1, 1, 0. Let's say sini point 0 and 1, 0 dia negative I. Negative I ke bawah lah. Negative I ke kiri lah. Negative I 1. Okay, negative I 1. So here 2, 1, 2, 1. Sini point dia pergi 2 negatif 1, 2 and then turun 1. So sini point dia. Okay, macam tu. So yang 2 ni negatif ke kiri. So moving to left, you moving to left, moving 2 point to left, 2 point 1, 2, and go down 1.1. So sambungkan, you dapat this vector function. Okay, and then you continue lah for the others point. So for the point negative 1, negative 1, negative 1, negative 1. So the given moving ke right 1 point and up 1 point. So sini. So semua tuju ke kosong. So you buat lah, sambungkan the others point lagi. Point sini, sini berapa. Cubalah buat. Nanti dia akan dapat, dia akan menuju the origin. Okay, this one we call as the vector vector field. Okay, this is how you can sketch for the vector field. So now we proceed to the operator. So the operator. So in the vector field, this one you need to know lah. You need to understand lah what is the formula here. So delta f. So delta that means partial for the each component in the function. Okay, in the vector field. Okay, this one we call as the gradient. Okay. So in other words, we can write as the f x y lah. Okay, or delta f x y z depend on question lah. Depend on question. Okay, either one, if either in the fx ataupun fx y, depend lah. Okay, so directional. So you dah dapat this answer. Okay, delta f, complete for delta f, you not need to dot u. The u is the unit vector. Unit vector is the form of the ijk. How to get the unit vector? So let's say you have the vector. Okay, let's say you have the vector u divided by u prime. Magnitude of the u. This one we call as the unit vector. Okay, and last one is the normal unit function. Okay, normal unit vector of the surface. Okay, for the unit normal vector, the formula is the delta f divided by magnitude of the delta f. Okay, so let we do for some example. Okay, this one to solve for the scalar function lah. To solve for the scalar function. So let's say we do for the some example, find the gradient. So the given the scalar function is the f x y equal x square y minus y cube. So to find the gradient equal to delta f. So delta, this one represent for the partial derivative. Okay, so the formula is the partial x I plus partial respect to the yj partial, because this one only have the two dimension x y, so just stop at the j. Okay, so just stop at the j. So to get this one, so you need to partial derivative lah. You need to partial derivative. Saya tukar kali lain. Okay, you need to partial derivative respect to the x. Okay, so sama dengan partial derivative respect to the x. So this one partial derivative respect to the x. So you akan dapat 2x y I. Okay, and then plus, so this one you need to partial derivative respect to the y. Saya tukar kali lain lain satu lagi supaya you tak keliru. So this one respect to the y. So you ambil semua balik. You look at the all this one, but respect to the y. So y here, so dia x cos 2. So y here minus 3y square j. So this one is the gradient. Okay, the gradient. So if the question given the point, find the gradient, this one at, let's say ada bagi 0, 1. Okay, so you need to complete here first, and then barulah you substitute with the point coordinate. So baru you masukkan if they given at the point, so you can get the answer 2 x kosong multiply y is the 1 I plus x kosong kuasa 2 minus 3 kuasa 1 kuasa 2 c. So the final answer you can get this one 0, so this one akan 3c. So the gradient at this point equal to 3c. Okay, this is the way lah how you can determine for the gradient. Okay, for the directional derivative, okay, directional derivative, this one directional derivative. Okay, directional derivative. So let's say the given, find the directional derivative, find du. Okay, du represent this notation refer for the direction of the derivative of scalar function. Given the scalar function fxy equal negative 4xy, okay, minus 1 over 4 x kuasa 4 x power of 4 minus 1 over 4 y power of 4 at 1 negative 1. Okay, this one point saya explained previously. So the point you need substitute after you get the derivative directional. Okay, in the direction, the direction of unit vector. Okay, this one u lah. U, this one the given lah, the given u equal, kalau the given you just use je lah, apply, just use the unit vector. Kalau tak bagi, you kena cari. Kalau dia bagi function saja, so you need to find the unit. If the given the vector, so you need to find the unit vector. Okay, to find the unit vector equal to vector divide by, let's say vector dia bagi vector, vector divide by magnitude of the vector, so you can get the unit vector. Okay, so the given here, so the first thing you need to find the directional derivative. So directional derivative, the formula is the, so du equal partial scalar function y, so you need dot u. Okay, dot u, so you need to find here first. Okay, so this one is the gradient. So gradient multiply dot dengan unit vector, so you can get directional derivative. So ataupun directional derivative, this one also known as the rate of change. Okay, so saya tukarkan lain lah. So you can determine. So look here, respect to the x. Okay, partial derivative respect to the x. So this one you akan dapat negative 4y. Ni tak, negative x kuasa 3, 4 bawa ke depan 3, so dia pangkal 4, so x power of 3. Semua ada x tak? Ada x, kosong lah. So equal dengan I plus j respect to the y, so dapat negative 4x. Respect to the y tak ada, respect to the y you akan dapat negative y kuasa 3. So this one represent for the j. Dah settle ni first, and then you need to dot product, dot dengan unit vector, so you get the answer. So derivative xy, you need to dot dengan unit vector, so 4y minus x square I plus negative 4x y cube j, so you kena dot dengan unit vector is the here, this one I, this one j, so 1 over 2 set to I, okay, plus negative negative 1 2 set to j. Okay, so dia ada dua ni lah. Okay, So for the dot, I dot dengan I, J dot dengan J. Okay, I dengan I, J dengan J. Tapi dia tak ada IJK, dia dah hilang. Okay, so you just dot kan. For this I to I, okay, so I dengan I dengan I, so dia akan jadi 1/2 set 2 negative 4y minus x kuasa 3 so plus 1/2 set 2, okay, set 2 negative 4x tolak y kuasa 3. So this is the final answer for the directional derivative. Okay, so the question asks at the 1 negative 1, so you kena substitute lah du at function 1 to negative 1. So you substitute lah y dengan x, x substitute dengan 1, y substitute dengan negative 1. So you complete all the answers. So my answer is the 3 set of the 2. Okay, this is the way how you can solve for the directional derivative. Okay, the last one we need to complete for the unit vector. Okay, unit normal vector. How we can solve for the unit normal vector. Okay, let's see the question given. Find the unit vector. Find the unit normal vector. Okay, to the surface z kuasa 2 plus 3y kuasa 2 equal x at point 5 negative 1 1. Okay, this is the way lah. Okay, the first thing you need to find the, so the formula is the n divided by n. Okay, so n, the formula n equal delta function divided by magnitude of the delta scalar function. So you need to find the delta f. So delta f equal dengan partial function terhadap x I plus function j partial z k. Okay, you need to find the gradient first. You need to find the gradient. So you look back. So this one you rearrange. Okay, 3D you rearrange so you can get let's say you use the others apa-apa surface for represent for the surface function. Let's say function x y z equal 2z square plus 3y square minus x. Okay, so you differentiate here respect to the x. Ada x tak sini, tak ada. Ada x tak sini, tak ada. Sini ada x, so jadi negative 1. So negative I. Okay, dah settle. So respect dengan y, ni tak ada y, this one ada y, so jadi 6y. So jadi 6y k. Okay, respect to the z, sini ada z, jadi 4z k. Okay, settle. So you dah already get the gradient. So you already get the gradient, and then you need to find the magnitude. Okay, absolute here. So this one equal dengan, for the x component kuasa 2 plus y component kuasa 2 plus z component kuasa 2. So this one you tengok kat sini dia just ada 1. Okay, 1 kuasa 2. Sini ada 6y. Okay, 6y kuasa 2. 6y kuasa 2. So sini ada 36 36. So plus, so 16 z kuasa 2. 4 kuasa 2, 16 kuasa 2. Okay. So this one adalah magnitude for the this one f. Okay, this one delta. Okay, so untuk dapat n, kita bahagikan je lah. Negatif I plus 6yj plus 4zk, okay, divide by 1 plus 36y kuasa 2 plus 16z kuasa 2. And then baru you tengok kat point dia lah. Point dia tu 5, negatif 1. So n dekat at the point 5, negative 1, 1. So you substitute lah the value. Okay, for the x 5, y negative 1 and z 1. So this one negative I. Okay, negative I tak ada apa. Y equal dengan 1, negative 1. Okay, j plus z equal dengan 1. So 4 1 k. Okay, settle. So you divide by 1 plus 36 y kuasa 2 negatif 1 kuasa 2 plus 16 1 kuasa 2. So 16 36 tambah 16 tambah 1, so dapat set 53. So n 5 negatif 1 equal this one, you dapat set 53. Tak kat luar lah, senang. Okay, tak kat luar je. Tak kat luar je. Ni 1 over set 53 negatif I plus 6J plus 4K. So this is the final answer for your negatif sorry negatif jangan salah, negatif. Okay, so this is the final answer for the unit normal vector. Simple kan, macam tu sajalah how you can solve for the unit normal vector. Okay, so saya tinggalkan satu soalan and try to solve the question lah, the answer lah. Okay, so saya bagi satu soalan, you cuba selesaikan. Okay, the given the scalar function, the given function f x y z equal x square y plus minus sorry, nanti mesti salah jawapan, nanti salah soalan, salah jawapan. Okay, so minus y kuasa 2z plus x z kuasa 3. Okay, the given scalar function. So find the gradient at 1 to 1 find the gradient. Saya tambah sikit lah. And unit normal vector at 1 to 1. And soalan ni soalan 1, soalan 2. Can find the directional derivative. Directional derivative at 1 to 1 in the direction of 3, 1, 3. Okay, saya sambung balik soalan. X kuasa 2, Y kuasa 2, tolak Y kuasa 2Z plus XZ kuasa 3. So, find the gradient and unit normal vector at the 1 to 1, okay. The second question, find the derivative, directional derivative at the 1 to 1 in the direction of the 3, 1, 3. Okay, that's all. So, you try to solve this question. So, dia dah cover lah. Cover gradient, cover directional derivative and normal unit vector. So, dia dah cover tiga-tiga yang saya ajar tadi. Okay, try to solve this one, okay. So, thank you all.